Number one, it's April 29th. All right, let's do this. Ooh, I sense the shift imbalance. Yeah, I think we have time to do not this one. This one. Find the numbers with even number of digits. Ha. Even number of digits. Huh? Are you kidding me? Even number of digits. So we just need to count how many digits we have. Huh? I think I'm gonna do I2S, and that's this function. Two string can do that. Oh yeah, okay. Oh. I'm gonna change my diet. I'm going to eat less carb during the day, and I should say during the week I'll only try to eat carb. So for the protein bars, so 2 times a day, because usually I train 2 times, so I'll eat carb basically 2 times, and then the rest of the time I'll just eat lots of other food. I mean, I do like legumes, so we'll do some legumes. Oh, and pretty much I can do this, right? Plus equal to, and then we say something mod 2 is equal to 0, right? And do this is going to be std to string n dot size. Pretty sure I don't need this. We can just return res. And tomorrow, yeah, I have to build like prototype stuff. There's always need to prototype stuff. All right, so nothing too much to see here. Let's try to implement this. I think all we need to do is, we can probably do SG, SF. No, 2025. I think that's, no, that's, I think I got it wrong. So 2025, 04110. Yep, I think that's the one. We just need to implement this one. Or at least I think that's what we need to do. So what is this? Find the largest number, and then we'll add limit base. So add 2 number based on the base. Okay. So we'll need to go digit by digit, right? Digit by digit. So we'll do 10 divided by 10. The next one, and eventually one of them will go. So okay. So we have x and y. So we have a result. So we go long rest. Okay. And while x larger than 0 or y is larger than 0. So yeah. Digit. So dx equal to x mod 10. Digit y equal to y mod 10. Oh, we also need a carry. So int carry. C carry is 0. I am not sure if the mod C++ mod. Can I have C++ online? Let's see. Minus 123 mod 10 and std and l. We'll do the exact same thing, and then we say this one divided by 10. Run it. Minus 3 and minus 12. I think that's exactly what we want, right? Okay, so now we can say we need to add them together and also add a carry, right? So s shall equal to dx plus dy plus c. Okay. When we do that, we have a remainder and a carry. Right, I have a remainder and a carry. So we can say remainder is going to be s mod base carry is going to be s divided by base, right? Actually, that's not true because c is already been defined. Right, so yeah, if we add it and we'll divide it by that. Yeah, let me think. Yeah, because nothing will be larger than the limit. Smaller than is no smaller than start. Okay, let me recheck this. Star larger than. This is the suffix number. Smaller prefix if start is larger than suffix number, then start prefix is start divided by that. Yes, we just remove the rest, and then we say this plus if start prefix. Oh, I think I didn't take into consideration the base here. Oh, that is wrong. If start prefix times, so I have star prefix, right? Times suff this plus suffix is larger or equal to start. So basically we have a start prefix, right? Start prefix. And we have to reduce everything down to limit. We cannot have them. Oof. Yeah, so basically the start is larger than the suffix, okay? And we will say it's larger than the suffix, and we get the start prefix. Okay, so we have the start prefix. Now, if the start prefix, and we need to fix it, right? We need to fix it. So we need to say, given a number, right? We're gonna return long cap digit. So we'll given a number, we'll cap the digit to limit. So what we can do is we could turn that into a string, right? And then or we can say res equal to 0 while n larger than 0. Okay. See, that is if you go right to left, that is harder to do because now you need to have a multiplier, right? Start with 1, mult equal to 1, and digit is n mod 10, right? N mod 10, and then we'll say if n is, now we can just say d shall be std minimum limit and d. Why don't we do it right here? Std minimum this and limit, right? That's a digit, and then res plus equal to d times multiplier. Of course, I'm going to change to long, right? Change the multiplier, and then res divided equal to 10, and the multiplier times equal to 10. Wait, what? No matching function call to min. Oh, wait, let's try it again. Min. What do you mean no matching function call? Have to be int. There you go. Right, so we have int, and then this, we get a smaller one, and res will times equal to this, because whatever it is, I'll time to the multiplier plus the previous, right? Multiplier plus the previous, and eventually we will return res. Okay, so this cap digit. Now we have this star prefix shall be cap digit of this, so we'll cap the digit limit, right? Wait, so we cap the digit. Once we cap digit, we got a star prefix. So this is the good star prefix. Nothing will be larger than the nothing will be larger than the limit, and then we'll try with this plus the suffix number. If it's larger equal to start, that is the smallest that we can get, right? That is the smaller we can get. But what if it's not? See, that is the thing. We use the original, right? And it didn't work, right? It didn't work. So since the original doesn't work, like if it's larger than, yes, then you already have it. But if it's smaller than, because we have capped it, right? We have cap, we put a cap on it. Now we have a cap on it, and it's smaller than start. Well, you can plus 1, but the question is, how much? Yeah, so basically we have the start, right? We have the start, and we need to find the smallest thing with a suffix num that is bigger than start, right? So basically what we say is we got a suffix and we get a start. Okay, we start, we divide by the remaining, and we put a suffix, and we compare if it's larger. If it's larger, then we're done. If it's smaller, like after we cap it, it's smaller. Okay. Yeah, what to do if it's smaller? But it's smaller basically means you have cap something, right? And we're talking about this is smaller. Can we have an example? I'm trying to think, but so the example is, let's say if the cap, its limit is 4, okay, and your small, let's say, is 98765, okay, then you have the suffix is 1, 2, 3. So you remove this, you put 98 into it, but 98 gets capped before 4, right? And then you're trying then you say, okay, I want to find the first one that's bigger than this. You increment this, right? You increment, but how do we increment? I see, man, this is the tough part. Yeah, you can't just say start prefix plus 1 because it's not the same. We have to cap it, right? So essentially we cap it, it becomes smaller. How do we find the smallest that's bigger than this? There could be many different reasons. When we cap it and become, because we're using the original, and then we are capping it, and boom, we cap it. So at some position, right, we'll cap. So essentially, we find the position that's the smallest, right? The position that we have the cap, and we need to move to the first one that will allow us to increment. But that's not true. It should be go from left to right, right? So left to right, we'll have the first one that's being capped, right? So to make it bigger, because like this is small, actually this is like 8 or 9, right? And this is small and I cannot increment this. So what I need to do is increment the 1 to my left. So I need to find the leftmost, right? Leftmost that has been capped. And this one has not been capped, means it's either the same or this one just one small, it's like maybe this is a 3 and this is a 3, and in that case I can increment this, right? So in that sense, cap digit. So cap digits is just, we just cap it, right? We just cap it, and if after recapping it's still good, then it's good. If it's not good, right? If it's not good, then for the capped, I think I need it. I need a start prefix. Unfortunately, I do need a start prefix, and also need a capped prefix. Cap digit, start, prefix, and limit. Alright, so now we have a capped prefix. And we'll do a capped prefix. If it's good, then it'll be a capped prefix. Otherwise, so this is the tough part. So otherwise, we need to compare the start prefix and the capped prefix, right, from left to right, and find the first one that has been capped, or find the first one, because I want the capped prefix to be bigger than the start prefix, right? No, I want the capped prefix times this plus of number, this whole thing, to be bigger than the start. But now this whole thing is smaller than the start, right? It's smaller than the start. So I will get this whole thing, right? Basically, we have this whole thing at the start. So we can go left to right, check every single one. In the first one, you increment, then it'll be bigger. But hey, this is the problem, right? This is the problem. The problem is it could be something downstream. Well, I mean, essentially, what we're saying is we have the start prefix, that's with the start, right? And it also has the other one has that. Yeah, we're asking what is the smallest. So we can also do I mean, it doesn't really matter, does it? Because the start, I don't really care about the, like, if the suffix is smaller, then yeah, we have to be bigger. If the suffix is actually bigger, then we can remain the same, right? Yeah. But suffix we cannot change. No, we cannot. And then unfortunately we have been capped. So some digits is small compared to the original. Yeah, so we do go from left to right. If they're the same, like if it's bigger than that, you can change everything else. It's not gonna matter. So you have to change from the left, from the biggest one, right? The biggest one, they have a difference. Yeah, because you capped it, so the biggest one, the leftmost, if there's a difference, right, because of your cap, and then we need to increment on the left, right, into increment on the left, and then that is independent of the suffix. So essentially, we have a star prefix, we have a capped prefix. We want to know, how do I change capped prefix such that it will be bigger than the start prefix? So I can turn those two, let's say, into strings. And then we this time have to go left to right, right? And the first one, the capped prefix is smaller, right? The first one when it's smaller, and then we need to try increment onto to its left. Ooh, okay. We increment it to its left. How do we do that? We make it bigger, right? But to make it bigger, yeah, I can add 1. I mean, it depends. So we find the first one that's different. That's because of the cap, right? So I look to the left, and if it's smaller than the limit, then you just add 1 to it, and we're done. And if it's equal to the limit, I have to keep looking to the left, keep looking to the left, until I find one, right? Yeah, that's basically how it's going to be done. However, how am I going to implement it? How am I going to implement this? I have to turn them into strings, and I'll compare the strings until we find one. And then what? We have this position, and then we go a while loop going to the left, right? A for loop, it doesn't matter, we go to the left, right? And the first one we find that is smaller than the limit, we'll increment it. But we're talking about making change to a string, which I don't think is possible. What other methods do I have? So I really cannot go right to left. So I cannot use the same trick. I mean, maybe you can. Maybe you can. Right? Maybe you can. I mean, I don't know. You can. Oh, this is a little bit convoluted though. A little bit convoluted. We need to. Okay, we identify the index, okay, and I will convert the number back into into the value, right? Or back into the value. Oh, so what you're saying is I'll compare the star prefix and the capped prefix. Can we just do that in the cap digit? Can we do that? Well, in cap digit, what we don't know is because in cap digit, once we cap, it is guaranteed that it will be smaller, regardless, right? Yes. Once we cap, it's going to be smaller. So what I can do is, as we move on, once we have a cap, and then I'm not sure. I'm not sure. And also there's a possibility that without capping, it's still smaller. Yes, it is. It's possible that without capping, that it will be still smaller. Then what? Then what? Well, then we just the same thing, right? We same thing. Okay, this is the same thing. Okay, so what's the strategy? We will get the index. We find the index where the leftmost cap happens. Okay, and then we'll loop to the left, the first one that we can increment. And that's the one that so okay, then we get the index of that one will be incremented. Then what? Then you need to manipulate the string into number, but you cannot change the string itself. So what you're gonna do is just gonna go index, index, index. If it's that, you will use the different one. And also you have to consider if everybody is the same, right? And if everybody is the limit, then you have to add one more to the left. Holy crap. This is getting more and more complicated. Maybe we want to write this as a function as well. What do we call this? Smallest that's larger than that's not alright. Okay, I don't like this idea. Okay, let's just do it here. So have a string of start prefix str. You can say toString start prefix. Okay, and then we have the capped prefix. String capped prefix str is going to be toString capped prefix. Okay, so now get these two. Then we'll say index is equal to 0, right? And then while I is smaller than these two shall have the same length. Therefore, I can just go start prefix string dot size. Okay, and we say okay, we're gonna do it here. And start prefix stri is equal to capped prefix stri. If they are the same, then we'll move forward, right? Then we just say I plus plus. Okay, so eventually when this one gets out, we have found the first one that's not the same, right? Not the same. And the reason for not the same is because of the capping, right? It's because of the capping. Okay. Next. Next. I need to go from left to right. So int j equal to I minus 1, while j is larger equal to 0, and capped j is equal to, holy crap, capped j, is that a character or, oh, I'm actually not sure. Hold on. Let's say 1, 2, 3, 4. Does foo 1 should be 2, right? Is equal to 2, or foo 1 or foo 1 equal to a string 2. invalid between. Yeah, there's some precedence, which is okay. Huh? Between pointer and integer. Pointer? Is it pointer? Wait. String at index. I don't understand. Like, what do you mean you cannot? You cannot do that? Alright, I am very confused now. Marvelously confused. So one of them is pointer. Oh. Okay, character equal. Oh, this is a pointer. String, it's a literal. Okay, this is what I understand. So this shall work because it's just a character. Yes, 1 means true, right? 0 means false. Yes, so it's gonna be character. Character I can do because limit is an integer. Oh, limit is an integer. So what I need to do is this character minus 0 shall equal to limit, right? We say if it's equal to limit, then there's nothing we can do, so we will move j forward, move j backwards, right? Or move j backwards. And blah, 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 blah. Eventually, j will go to a certain position, and that's the one that we can make a difference. That's the j we can make a difference, right? How are we going to make a difference? Can we string replace character? I don't know. Is it possible? Ochar, no char, dot replace. I see. I can use that. I cannot use that. I cannot use that. This is replace every single one. Replace at index. Really? You can do it that way? Alright, this is something I thought I cannot do. I thought this is illegal. You basically define a string, you have an index, and you go through that, and you just change it to a new value. I am very surprised. Okay, this is something I did not know. Oh, that makes things easier. Can I also, let's say my string, can I also do, let's say 1 plus my string. Can this one work or this one? Oh, wow. Huh, okay. Now that actually makes things easier. So yeah, so J is the first one that can do something, right? Then we shall say if J is larger equal to 0, and we are going to say capt prefix str J shall equal to capt J minus 0 plus 1 plus 0. Oh, then you just do plus 1, right? Yeah, because character can plus 1. Character can do that, right? So yes, we do just do this plus 1. Else, which means it's smaller than 0, then capt need to add. So capt shall equal to 1. Yeah, we need to add a 1 plus capt, right? str. And smaller, this is, we're gonna say capt std s2 long. The small prefix has to be long. This is gonna be capt. Okay, so that's how we're gonna do it. Madre mia. We still have this one to go through. Yeah, this is also not right. We have to go through pretty much the same thing. All right, but I'll leave this for another day. Wow, this one is gonna take a very long time. And I'm pretty sure, I think the official solution is Fenwick tree. Yeah. All right, anyway, I'll